Hi everyone. First of all, welcome to everyone. Welcome back, and hopefully everyone is back all in one piece. And we come back just when level 4 lockdown has just changed to uh, level 3. Uh, for now, with the online plan for technology side of things, technology for design, um, this is how it's going to work. So we have a slot on Monday that is 3 hours. Is it 3 hours or 2.5? But that's the longest slot we have. Um, then we have another slot on Thursdays, which is just 1 hour. So until we hear otherwise from the university and maybe department, this is how we're going to work. Every time on a Monday, I will upload an audio guided lecture slides. In the lecture, I will make a point that there is at least one task that you guys have to do um, in the slot on a Monday, the long slot. So that should be possible to do. It will be due at the end of that time slot, not at the end of the day, because the plan is for you guys to do it in the lecture slot. It will be just a small task that you have to do in the lecture slot. Then the topic that we would have covered on a Monday, we will have a test on Blackboard every Thursday based on that topic and the previous topics that we would have covered. So, overall, on a Monday, normal lecture online, audio guided one. You guys download it or watch it and you study, you do additional research. There's a task that you need to submit before the end of the lecture slot on a Monday. Then on Thursday, there will be a test. It can be a multiple choice, short questions, or long questions, but Thursday slot will be dedicated towards having a test of some sort or a longer task of some sort. Cool. Hopefully that makes sense, but we can clarify this as we go along if anyone uh, doesn't understand. So today, uh, before I come to today, you would remember that in our previous lecture, just before we went for a break, we started lectures on metallic materials and we introduced metals and we've covered ferrous metals. So this one will be covering non-ferrous metals. So the task that you're going to have today in this lecture slot will be based on what we covered before we went on vac. Even the test or the longer task that will be this coming Thursday will be based on the previous material but likely to include what we're covering today to keep that consistency of what we do on a Monday. We have some task based on that in addition to the one that would have popped up in the lecture slot itself. There will be a longer one for more marks on a Thursday. Cool. So today we're doing non-ferrous metals to complete the topic under metals, metallic materials, ferrous and non-ferrous. So we covered the ferrous one. Now we're doing the non-ferrous metals. It's a very short one, and just enough for you guys to get back to the swing of things in term 3. So I've touched on this already, the content that we've covered. We did some introduction to metals, and then we've covered ferrous metals. We looked into the classification of steels and why are they steels, and stainless steel and why are they stainless steel. And today we're doing the non-ferrous metals, which are sometimes called light metals. Then I just have to see if we need to cover metallic processing or metal processing before we do corrosion, or corrosion before processing. That will depend on if there is a requirement to align to whichever projects you will be doing with other subjects. So just to recap, we know now that when metals are made, they start with the molten metal. That molten metal solidifies, and during the solidification process, the atoms are arranged in an orderly fashion. The basic order with which they arrange are called unit cells. And then there are different types of arrangements that we've covered: the body centered, face centered, and hexagonal close packed, which are the three that I said we focus on. And then these unit cells next to another unit cell, as they grow, when the molten metal solidifies, they form what we call crystals, or the lattice structure. So metals made of crystals or lattice structures. And we've covered that, we've seen that in the crystal itself, or the lattice structure, there are imperfections which are good for the metals. Otherwise, we wouldn't be able to work with metals. So you guys should know all those imperfections, all this we've covered. Then the crystals can grow as the one type of crystal, which would be the single crystals, or it can be different crystals in terms of arrangements and substitution and replacements of other atoms, in which case there will be polycrystals. Depending on that, you will have different applications because there are different metals. That was just a recap, and we've covered all that. So today's task, since we've covered now the steels and stainless steel, this task has to be completed before the end of our slot today, which is 12:30. So you use the slides that are up already and or your additional research. So all you have to do for 16 marks, properties of stainless steels. So we covered martensitic, ferritic, austenitic, and duplex stainless steel. All you have to do is to say whether these stainless steels, martensitic for instance, its corrosion resistance, is it low, is it high, is it good, is it excellent, because they are all different. Then you go to the hardness, is it low or hard, or is it medium, that type of stainless steel. Then magnetism, what are the magnetic properties of these stainless steels? Does it have magnetism? Yes or no? Then weldability. How is the weldability of this stainless steels. Is it good? Is it poor? Is it limited? Is it excellent? So just one word, one word, one word, one word for all of them. That is due before the end of today, not before the end of today, before the end of the lecture slot, as per the timetable. Cool. So in a bit more detail, and I did say it's a short one, the light metals or non-ferrous metals. So the non-ferrous metals, in line with the definition or the explanation that we gave earlier or in the previous lecture, comparing the ferrous with the non-ferrous, we said the ferrous metals, they have iron as the parent element. On the other hand, the non-ferrous are the ones that do not have iron as the basic ingredient. And then we said ferrous metals rust or they corrode because of the fact that they have iron. The non-ferrous metals are important because they possess properties such as the corrosion resistance. They also have high thermal and electrical conductivity. They are very light, hence they are called light metals alternatively, and they are easy to work with. These are the typical non-ferrous metals. I've given you a few pointers of each non-ferrous metal and its alloys, just to differentiate in addition to the general properties or characteristics. So this will be the aluminium ones, and then that will be the magnesium ones. Comparing magnesium with aluminium alloys, magnesium is like very light. The density is 1.7 compared to 2.7 of aluminium. So the importance of this will be the applications that you might be interested in or that make these metals suitable would be based on things like this. And I did mention before that it's not the choice of a metal is not based on a single property. It is a property attribute. It's the property attribute set of properties that are chosen to best fit the desires or requirements of the application. Unique things about magnesium, it ignites very easily. Now you find it in missiles as well. That's why it ignites very easily. They also use it in aircraft as well, as they do with other non-ferrous metals like titanium. Also very low density but a bit heavier compared to the other two. It is very reactive at high temperatures, common in space applications. Then you have some noble metals. These are sometimes called precious metals. These are your platinum, silver, and gold. They are termed precious metals. Why? Because of their cost. And because they're very expensive, they are commonly used as plating or filling metals. Then there are refractory ones, which are very suitable for high temperature applications. There's many more. I just chose this few to compare the properties within the general attractive properties of non-ferrous. They have their unique properties that will make them suitable for their respective applications. So the general characteristics of non-ferrous metals, besides their individual properties, in general, these metals are usually found in the industry or are used in the industry because of their general characteristics, which include the ease of manufacturing. Manufacturability is very good, very easily, and their resistance to corrosion. And we know now why they are resistant to corrosion. And again, generally, they have electrical and thermal conductivity. And finally, they generally are light metals. That's why they're called light metals, ferrous metals. Those four unique or general characteristics are what makes these metals common in the industry applications. So, stiffness, which is elastic modular, compared to iron, look at how low they are, the non-ferrous metals. And in terms of melting point, again compared to iron, it melts at a very high temperature, and they melt at lower temperature, well, except titanium, which is very attractive in space, because of it's very light, but it can withstand high temperatures. In terms of density as well, they have different densities, lower compared to iron. Then resistivity, what it means is a property of a material which resists the flow of electrical current. It is lowest in copper. That's why copper is used as a conductor commonly, because resistivity is low. The property of material to resist electrical flow of current, it's low there. That's why for copper it is used as a conductor. Cool. Hopefully that makes sense. And that is the end of non-ferrous metals. Uh, this was very short because we're going to look at the metallic material processing or processing of metals, which will focus a lot more on the non-ferrous metals, but then not in isolation. We're going to look at ferrous metal processing, but a lot of topics overlap in terms of processability, because that is key to the non-ferrous metals because of their manufacturability. So a lot will be covered in metallic processing. Cheers, guys.